All right, here's the homework for evaluating limits that are indeterminate. Indeterminate means if you evaluate, you get 0 over 0. And when that is true, one of the techniques is to factor. So if I factor the numerator and look at the denominator, I can remove the discontinuity and then evaluate at 3 and get my answer. So again, I first recognize it is indeterminate, then I can factor. And then after I factor, I can remove the discontinuity, plug in 2, I get 1 is left in the numerator, and -5 in the denominator. For number 3, again, we're going to use factoring to eliminate the discontinuity. So the numerator is a difference of squares. The denominator, the two numbers that multiply to -3 and add to the +2, +3 and -1. Recognize the discontinuity is removed, plug in -3, and then you can reduce it down if you like. Number 4, a little more fun. Again, it's indeterminate. So to factor this, I'm going to factor out x squared. That leaves me with x subtract 5. I'm going to factor out a 6. That's x subtract 5. The denominator, again, is fun again to factor. So 2 times -25 and -5. So the two numbers we're going to use are -10 and 5. So in the denominator, take out the -5x and put in -10 and +5. And then factor by grouping. So factor out an x. Oops, let's do it right. So factor out an x, and you get, factor out a 2x, and you're left with x minus 5. Factor out a 5, and you're left with x subtract 5. So come back. So we have x subtract 5, and then 2x plus 5 left over. Recognize that x subtract 5 can be removed. So we have x squared plus 6, 2x plus 5. Reevaluate at 5. So that's 25 plus 6. That's 10 plus 5. And you have your answer. Number 5. So step 1 is to recognize it's indeterminate. So if I evaluate at -2, you get 0 over 0. Then we're going to factor. So it's good practice knowing how to factor. So I'm going to factor out x squared, that's 3x minus 1, and factor out a -4, that's 3x minus 1. And then in the denominator, I'm pretty sure 3x subtract 1 is going to be removable. Maybe not. Maybe, oh no. Well, let's see. Is it 3x subtract 1? 3x plus 1 because it's positive, right? So 3x plus 1 and x plus 2. So that gives me 3 times 2, that's 6, plus 1, that gives me 7, so it fits. So we're not done yet. So we have 3x subtract 1. That does not eliminate 3x plus 1. I have x squared subtract 4. That's a difference of squares. So that's x plus 2, x subtract 2. And then x plus 2 is removable. And then evaluate at -2. So that's -7, well -6 subtract 1, -7 and -4. So that's 28. Evaluate at -2. So that's -6 plus 1, that's -5. So I get 28 over -5. Number 6, evaluate at 1, and now we need to do some factoring. So I'm going to factor the numerator. Those two numbers are 5 and -3. That gives me 3x squared plus 5x, subtract 3x, subtract 5. Factor, group out the x, and then -1. So there's the numerator. So we got x subtract 1 and 3x plus 5. If I factor out the denominator, I'm going to use this fact that x subtract 1 needs to be removed for this to work. So if it is removable, then a factor, that's going to be the common factor that gets removed. So then what's left would be then 2x plus 7. So that's negative 2 and positive 7, so it does fit. It's removable. Now evaluate at positive 1. That's 8 over 9. All right, number 7 and number 8. This is called the difference of cubes. It does happen once in a while. The cube root of x and the cube root of 27. So what number 3 times itself? That's a good place to start. Then what's left over is x squared minus plus. Yeah, plus. So what I'm doing is the cube root and cube root. So I use x minus 3. I then square it. I multiply them together and then square 3. And that's like the little formula we use. Oh, and it's minus 9, isn't it, for it to fit? Right? Or no, it's a plus 9. Can't be minus minus. It's a plus 9. For it to fit, the denominator, I'm going to assume that x subtract 3 would be eliminated. If that's true, then what I'm left with is 5x plus 2. And I make sure it works. That's negative 15 plus 2, so it does fit. This is removable. Plug in 3, and I get 9, 9, 9. That's 27. 3 in the bottom, I get 15 and 2, that's 17. So I get 27 over 17. Number 8, another difference of cube, or sum of cubes. Let's try this one. So the cube root of 8x cubed is 2x. And the cube root of 1 is 1. So in the numerator, I have, starts with 2x plus 1. These are all going to be and then it'll be 4x squared minus 2x times 1, which is 2x, and then plus 1 cubed, 1 squared, which is 1. I'm going to factor out 2x. That's 4x squared minus 1. That's a difference of cubes. This is real heavy factoring. A difference of squares. So we had a sum of cubes, a difference of squares, factor out a greatest common factor. This is heavy algebra. Square root both, and you get 2x plus 1 and 2x subtract 1. And then the removable discontinuity there, and then plug in 1/2 to get your answer. So you plug in negative 1/2, negative 1/2, negative 1/2, negative 1/2. And your answer is 3 over 2. Done. Number 9. Oh, is that the whole thing? Oh no, it's a 2-pager. So where is the second page of the homework? I think that was it. So this is the homework I want you to do, is up to page number 8. I think there's a second page, but it's the second part of the lesson I didn't teach. So Mr. G Math over and out. I'm proud of you for doing your work. And until next time, I'm trying to think. There's got to be one with rationalizing. So let's see where I might have put that one. Did I lose it? I'm going to give myself one moment to try to find it. Where I can rationalize it. So where is the one with rationalizing to practice? I don't think I printed it out. All right, there's going to be a part 2 to this homework. Mr. G Math over now.